Hi, I'm Caroline Alliston, a professional engineer, STEM educator and TTS consultant. This is what we're going to make today. It's a model sailing boat. I'll show you how it works. You'll need polyethylene foam packaging, a long pencil, an old cereal box and some decorations. If you don't have any foam packaging, then you'll need to improvise with other things that float. For example, here's a boat made from plastic drinks bottles joined with sellotape and a milk bottle lid with a hole in it to mount the mast. And here is a boat made from corks joined together with cocktail sticks. And you'll need a serrated knife, ruler, felt tip pen, chopping board, scissors, hole punch and cocktail sticks. If you have a glue gun, you can use it instead of cocktail sticks to join the boat parts together. Or you could try using double-sided tape or sellotape. You also need something containing water for you to sail your boat. For example, you could use a shallow plastic box like this, or a large roasting dish, a sink, a bath or a paddling pool. Step 1 is to make the hull of the boat. Decide what shape you would like your boat to be. Here are a couple of examples. Use the ruler and felt tip pen to draw the shape of the boat on the polyethylene foam. I'm planning to make a catamaran. Use the serrated knife and chopping board to saw up the polyethylene foam. Be careful not to cut your fingers. If you're too young to use a serrated knife, then ask an adult to help you. Use cocktail sticks to join parts of the boat together. Cut off the sharp tips of the cocktail sticks before you use them so that you don't spike your fingers. Step 2 is to make the mast support. Cut a cube of polyethylene foam about 3 cm across. Use 2 cocktail sticks to attach the cube somewhere towards the front of the hull. Step 3 is to prepare the sail. Use the ruler and felt tip pen to draw a sail shape on the old cereal box and cut it out. It should be slightly shorter than the pencil. Use the hole punch to make a hole in the middle of the top and bottom of the sail. Enlarge the holes until the pencil just slides through both holes. Step 4 is to fit the mast and sail. Push the pointed end of the pencil through both holes in the sail, then vertically downwards through the foam cube and into the hull of the boat. Step 5 is to add the decorations. Add any decorations you have to the boat. You could take the sail off to decorate it if you like. Step 6 is to try out the boat. Place the boat on the water and check it floats. Blow into the sail to make the boat go. How fast can you get it to go? Does it go in a straight line? Step 7. Try making some improvements. You can make changes to the boat. You could try and make it more streamlined so it goes faster. You could add outriggers to make it more stable. You could try fins, a keel or a rudder to help it go in a straight line. I'll just make this one a bit more streamlined. What else can you do? Collect together a set of materials such as a lolly stick, marble, pebble, coin, plastic connects and foam packaging. Hold each in your hand to feel the weight. Separate these into items you think will float and items you think will sink. Identify the materials these items are made of, for example plastic, glass, wood, rock and metal. Place each one in the water to see if it floats or sinks. Can you work out why some objects float and others sink? Now my son, who is a physics student, is going to tell you about the science behind the project.
Here is a diagram to explain buoyancy. Gravity pulls objects down towards the water. The more the object weighs, the more the force pulling it down. The object is pushed up by the upthrust or buoyant force, which is equal to the weight of the water displaced by the object. If the force pulling it down is more than the force pushing it up, then it will sink, as in the sinking case. So if an object is denser than water, that is to say it weighs more than the same volume of water, then it will sink. If it weighs less, then it will float. You can try and judge for yourself whether an object is dense by holding it in your hand to see if it feels heavy for its size. Metals, glass, most rocks and plastics are denser than water, so they sink. Here are some metals. Here are some glass marbles. And here are some rocks and plastic. Plastic. And our rocks. Pumice is a rock, but it floats. We can understand this by thinking about where pumice comes from. Pumice stone is formed during volcanic eruptions as lava flies through the air and goes solid very quickly. It has lots of holes in because of the gas contained in the molten rock expanding as it's ejected, which forms bubbles. These bubbles are then kept in place because it goes solid so quickly. These gas bubbles cause the density of the rock to go down, so it floats. The polyethylene foam packaging also contains bubbles of air and is very low density, so it floats really well. We use polyethylene foam for this reason, and because it's easy to cut out with a knife and join together with cocktail sticks. Most ships are actually made from a metal called steel, which is much denser than water, about 8 times. The reason the ship floats is because it contains lots of air, so overall the ship is less dense than water. Here's my ship. When the Titanic hit an iceberg on its maiden voyage to America, several of the steel compartments, which were full of air, were ripped open. A lot of the air escaped and was replaced by water, so the ship sank. Here is my simplified model. The ship has sunk. The boat is propelled forward by blowing into the sail. Friction acts to slow the boat down. Most of this is friction from the boat moving through the water. This can be reduced by making the boat more streamlined so that it cuts through the water more easily.
This project is taken from the TTS Key Stage 1 to 2 STEM Activity Cards. Here are some more examples of projects taken from these cards. Magnetic fishing game, juice carton guitar, density tower, ooglies, Cartesian diver,